Hi and Assalamualaikum. In this video, we are going to talk about the application of the derivative. Before we going to talk more about this topic, first I'm going to talk about the introduction. Differentiation in mathematics is a process of finding the derivative or rate of function. Differentiation is the process of deriving f prime x to fx. F prime x is called the derived function or derivative of fx. Next, I'm going to talk about the application of differentiation in real life. There are two applications of differentiation in real life in this video. The first one is calculating pressure within dams. Let us consider a dam. When the reservoir behind it is full, the dam withstands a great deal of force. We can use differentiation to calculate the force exerted on the dam when the reservoir is full, and also calculate how changing water levels affect that force. Hydrostatic force is one of the many applications of differentiation. The second one is automobiles. In an automobile, we always find an odometer and speedometer. Their gauges work in synchrony and determine the speed and distance the automobile has traveled. The electronic meters use differentiation to transform the data sent to the motherboard from the wheels, which is a speed, and the distance, which is a odometer.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AQEEL bin RUDY MARZUKI. So I'm gonna take a part about the application in questions, which is from this part, there is 5 things that we will learn about it. The rate of a change of the quantities. Second one is the increasing and decreasing of the fx, and tangent and normals, force about the approximations, and then lastly, fifth, minimum and maximum. But in focusing of our titles, we will going to be the rate of change of quantities. Well, moving on, which is on the problem statements, which on the related rate. One of the most fundamental concepts of calculus is the fact that derivative is used to model the change. We will try to find the rate at which one quantity is changing by relating to other quantity with known rate of change. Well, in our problem statement, we are provided there is 5 steps we will learn about it. For the first one, step 1. Identify the rate of a change that are known and the rate of a change that is to be found. Intercept each rate as derivative of the variable with respect to time, and provide the description of each variable involved. Step 2. Construct a formula or equation that relates the variables in step 1. In a geometric problem, this is aided by drawing an appropriate label figure that illustrates a relationship involving these variables. Step 3. Differentiates both sides of the equations. Last 2 from the problem statement steps. Step 4. Evaluate the equation found in step 3, which is after differentiates, using the known values for the quantities and their rates of a change at the moment in questions. Lastly, step 5. Solve for the value of the remaining rate of a change at this moment. There is example questions we will be looking for it. Let us read the questions. A conical water tank has a radius of 3 cm at the top and 50 cm high as shown in the figure 2. Water flows into the tank at a rate of 6 cm per cubic per second is shown by this figure. These questions will be solved by using a video tutorial from HARIZ AFFANDI.
Hi, now I'm going to show you the solution for this question. Firstly, let's bring out all of the information given in the statement. Here, it states that the radius is 3 cm, the height is 15 cm, and this we can consider it as dV over dt, 6 cm cube as the power of -1. And lastly, volume of cone is 1/3 pi r squared hash. So we have got all of the information given. So let's solve the question. The first question is, show that the volume of water is given by V is equal to pi hash cube over 75. Firstly, we can use the equation of volume of cone, which is 1/3 pi r squared hash. So we need to modify this equation into this. So the first thing we can do is we need to find ratio of radius and height, which is 3 and 15, or we can write it r over hash is equal to 3/15. And here we can simplify it 1/5. So take a look back at these two equations, which is the equation we need. There is no arc, but there is arc here. So we need to remove the arc. In order to remove the arc, we need to make this equation into the term of hash, which is we can move the hash to the other side, and it will be 1/5 hash. So we have found our arc here. We can substitute it into this equation, which is we can find the V is 1/3 pi r squared is 1/5 hash squared hash. So we can expand in this bracket will be 1/25 hash squared hash, and we can expand it 1/3 pi 1/25 hash cube. And lastly, we can get our V is pi hash cube 25 multiplied by 3 will be 75. So that is the answer for question 1. Next question is, how fast is the height changing at an instant when the height of the water is 5 cm? The words here means that we need to find height, which is dV over dt, the fast of height changing. We need to find dH over dt when the height is 5 cm. In this case, we can use dV over dt in order to find dH over dt. Firstly, we need to find what is dV over dt. We can use V is equal to pi h cube over 75 in order to find dV over dt. So we need to derive this equation. To make it easier, I will write it in the simpler way. 75 pi h cube. So dV over dt here is 1/75 pi h cube. Hash squared multiply with dH over dt. So we can simplify this, and lastly we can find that our dV over dt here is 1/25 pi h squared multiply with dH over dt. So dV over dt is 1/25 pi h squared dH over dt. So now we can substitute all of the information that we can into the equation, which is dv over dt is 6 1 over 25 pi h squared is 5, just as in the question given, and multiply with dh over dt, and this will be 25 dh over dt, and we can simplify this, and it leaves pi dh over dt. And lastly, in order to find dh over dt, we can move pi into the other side, and lastly we can get our dh over dt is 6 over pi units. And that's the answer for the second question. So that's all for the solution for this question. Thank you.
Lastly, the conclusion. To summarize, related rates problems involve determining the rate of change of one variable while other variables are also changing. These problems require careful analysis, identifying relevant equations, and applying differentiation techniques. By understanding related rates, you can solve real-world problems involving changing quantities and their interconnections. And always remember that practice is a key to mastering related rates problems.